Alright, hello everybody. In this video, I will be reviewing how to solve a trig equation. And we're going to look at that with two different ways. We're going to look at that as a primary solution or a solution over a specific interval, and then also as a general solution, which is getting all possible solutions. So if you have your packet, this is page 61. Otherwise, it's going to be Trig 9A solving worksheet. And I'm going to go over the first two examples on page 61 and then going on to page 62. All right, so the first thing that we can do is look at what we have right here. And we are looking at, for letter A, find all solutions to 2 times sine of 3 theta plus 5 equals 3. So what we really need to do is get this solved for the sine of 3 theta. So we're just going to subtract the 5, and I'm going to get 2 times the sine of 3 theta equals negative 2. And now I'm going to divide each side by 2, and I'm going to get the sine of 3 theta equals negative 1. So what's happening here is, if you think of your parent function, the sine of theta, this is going 3 times as fast. So you have 3 waves between 0 and 2 pi. So our period, remember, is 2 pi over b. So our period is going to be 2 pi over 3. And then this is going to be looking like the parent sine function, except going a lot faster. If you want to think about the interval, you certainly can. Remember, when we do the interval, we divide this by 4. So you're going to have 2 pi over 3 divided by 4. So that'll be 2 pi over 12, which is pi over 6. Okay? And we're starting at the center line. There is no vertical shift in this corresponding function. The amplitude is still going to be 1, and there's not a phase shift. So all that's happening is your period is 2 pi over 3. So I have 2 pi over 3, 4 pi over 3, and then 6 pi over 3 is going to be 2 pi. Halfway, you're going to be at the max. Halfway, you're going to be at the min. No, halfway you're going to be at the center line. Sorry about that. Halfway you're going to be at the center line for each one. And then between that, we have our max and min. So that's where this is going to be pi over 6, 2 pi over 6, 3 pi over 6. Down here, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, which reduces, 10 pi over 6, and then 11 pi over 6. And you can kind of get your waves there. So here we go. All right, so that's what the graph looks like. So there's really 2 ways you can do this to solve. So the first way, and you can see I kind of struggled with it a little bit, was graphing the actual function. Graph the function. Okay, this is not the way that I would recommend, actually, but this is definitely what you can do. And if you look, I want to know, where's the sine of 3 theta negative 1? So here you have negative 1 for your output, and I want to figure out what my input would be. And so this is happening at pi over 2, 7 pi over 6, and then 11 pi over 3. So now this is find all solutions, but over a specific interval. So let's say the interval was from 0 to 2 pi, and you might see that written like so. Okay, using our interval notation, then you would say the answers would be pi over 2, 7 pi over 6, 11 pi over 6. Okay, that's getting your specific solutions over an interval, so that's getting the primary solutions. If you're getting the general solutions, which is what this question asked for, we would now need to try to come up with a pattern. So this is 3/4 of the way of this period because you're at the minimum value. So -1 is going to be your minimum. So, and I'll show you another way that we could get that, but you're going to get pi over 2. And then we're going to add the period, which is 2 pi over 3 times k, where k is an element of all integers. And I'm going to give you the real fancy notation here just so you can kind of see it. So this means is an element of, and this means integers. Okay, and that's actually our solution to this question. But practically speaking, that's not actually how I would do this one. So graphing the actual function and figuring out the general and primary solution from a graph is kind of labor intensive. You could see I kind of struggled with that. All this answer is saying is once you find the first solution of the pi over 2, you can keep adding or subtracting the period, because remember integers are positive and negative, to get all of the coterminal solutions. So that's what this is saying. So if you add 2 pi over 3, you're going to get the 7 pi over 6, and then the 11 pi over 6, and then I could go in the other direction as well. That's not how I would actually do this one. All right, the second way is to substitute. All right, and I think your answer key, if you use those, I think I use the letter T, but this time I'm going to use the letter A, only because some of the problems have T in them. So I'm going to let A equal 3 theta. Okay, and we had already solved this way at the beginning. So now I'm just going to say the sign of A equals -1. So this is going to be sine of A equals -1. And now in our second way, you have 2 possible ways to get your solution. So there's kind of a subset. So letter A is the parent graph, and letter B is the unit circle. Okay, so if you think of the parent graph, and you don't need to go crazy with this, but remember, sine starts at your midline and ends at the midline, so halfway through you're back at the midline, and this is your first quarter, midline, halfway, 3/4 of the way, you're at your minimum, and then back to your midline. Here is going to be -1. This is going to be 3/4 of the period of the 2 pi. So that's where you should be getting the value here of 3 pi over 2. So remember 0, pi, 2 pi, and then this is pi over 2. If you quarter 2 pi, you're going to get pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So you're going to get 3 pi over 2. And I just want to show you another way that you could have gotten that. So remember, sine pertains to your y value. So you want to look for a y value of -1 on a unit circle. So here's my unit circle. Here, y is -1, and I can easily pull off 3 pi over 2. So that's getting the angle for that particular output. So in a couple of different ways, I'm getting the 3 pi over 2. So now I know A equals, I'm going to write A equals 3 pi over 2. But I did a substitution, so I'm not really solving for A, I'm actually solving for theta. So now I'm going to say 3 theta equals 3 pi over 2, and I'm going to solve by dividing each side by 3. And I'm going to get pi equals 3 pi over 2 times the reciprocal of 1/3. The 3's cancel, and you're going to get pi over 2. Okay, and that's what we got over here. So I have pi over 2, and now we do have to find the period no matter what, and I did that way back here at the beginning, so the period was 2 pi over 3. So I have pi over 2 plus 2 pi over 3k. Same thing, where k is an element of all integers. All right, now let me be honest with you. So let's say the interval here was from 0 to 4 pi. So if the interval was from 0 to 4 pi, you would keep adding or subtracting 2 pi over 3 until you got all values within this particular interval. Okay, and that's how you would do that if you were looking for a specific, like a primary solution over a specific interval. All right, let's go on to page 61. All right, and now letter B says find all solutions to negative 12 times the cosine of 5 theta plus pi over 2 minus 5 equals 1. So I'm going to skip that graphing method. I'm going to go right to the substitution here. But before I do that, I am going to go ahead and solve. So I'm going to add the 5. I'm going to get negative 12 times the cosine of 5 theta plus pi over 2 equals 6. I'm going to divide each side by negative 12. So I'm getting the cosine of 5 theta plus pi over 2 equals negative 1. Okay, and now what we're going to do is we are going to let A equal 5 theta plus pi over 2. So therefore, I have the cosine of A equals negative 1/2. This one's going to be quite a bit harder. When you think of the graph of the parent cosine, this is just going to be a harder problem. So you're starting here at max. Remember, you end at the max, halfway you're at the minimum, and then at your quarter values, you're down at the center line. And so this is the graph of the parent function going from 0, pi, to pi. And I want to know where over that interval is your output going to be negative 1/2. So if you look over here, that's happening twice. Yikes. It's happening twice. Okay, and so to get that actual value here is kind of tricky. So I actually would go to the unit circle. This is just telling you that you can get it twice. I would just look it up online, have a unit circle that you can reference and that sort of thing. But this one was looking at cosine. So just a reminder, cosine is always pertaining to x. So I'm looking on here for x values of negative 1/2. And that occurs here at 2 pi over 3. And again at 4 pi over 3. So it's happening in 2 different spots. So I'm going to write that down. So I'm going to get 2 pi over 3 and 4 pi over 3. Okay, the other thing that I am concerned about is the period. So the period here is going to be 2 pi over b. So 2 pi over 5 is going to be my period of the original function, which is important for me. So I will need that later as we get our final solution. So now remember, this is what A equals. So I got A equals 2 pi over 3 and A equals 4 pi over 3. So now I actually have to go through and substitute. I'm going to have to do this twice. You are going to need a little bit of room. So I have 2 pi over 3 equals 5 theta plus pi over 2. And I have 4 pi over 3 equals 5 pi plus pi over 2. If you're feeling up to the challenge, by all means, go right ahead and solve those on your own. You can pause the video here and solve those 2 equations to see what you get and verify your numbers. The fractions are going to be a little bit of a pain to deal with here. I am going to need a common denominator as I subtract the pi over 2. I'm going to have to do that for both equations. So I'm loving that right now. So I'm going to rewrite these as 4 pi over 6 minus 3 pi over 6 equals 5 theta. Okay, and then I'm going to kind of rework this. So I'm going to put the 5 theta on the left, and I'm going to have 5 theta equals pi over 6. And now I'm going to divide each side by 5. So I'm getting theta equals pi over 30. So remember, this is like multiplying by 1/5. Okay, so when you divide by 5, you multiply by 1/5. So I'm getting pi over 30, and then I'm going to come back and revisit that to write my final answer. All right, and then over here, I have to pretty much do the same thing. So I have 4 pi over, no, this time I don't. I have 8 pi over 6 minus the 3 pi over 6 equals 5 theta. So again, I'm going to rework it. I'm going to put the 5 theta on the left, and that will equal 8 pi minus 3 pi is going to be 5 pi over 6. And now when I divide each side by 5 and I multiply by 1/5, here the 5's cancel and you're going to get pi over 6. Okay, so I'm getting theta equals pi over 6. So if you were looking over a particular interval, now what you would do is you would add the period of 2 pi over 5 to get the values within that interval for both of these, and then that would be all that you need to do. For the general solution, which is what this is asking for, you're just going to do pi over 30 plus the period is 2 pi over 5 times k, and since there's two sets of solution, you're going to have pi over 6 plus, again, 2 pi over 5k for both of these, where k is an element of all integers. And that would be your final answer for this problem. All right, I hope this helps. Have a great day.